Hello students and welcome to the lesson on solving inequalities, and we are dealing particularly with quadratic inequalities. Okay, so we've dealt with quadratic equations before, and now we're going to solve some inequalities that have a quadratic in them. Okay, so I've got a problem here that says solve for x squared plus 3x minus 28 is greater than 0. And keep in mind that for quadratics with equations, there were two solutions at a time. For inequalities, there will likely be an infinite number of solutions, and so our answer will itself be an inequality. Okay, so um, to start off here, I want to know for which values of x will this entire expression on the left side be greater than 0. So I'm going to start out by solving for zeros, okay, or x-intercepts. So in order to find out for which values this equation is greater than 0, I actually have to start by solving for when it is equal to 0. So let's try it. X squared plus 3x minus 28 is equal to 0. And so I want to find the x-intercepts first if I were to graph this. And so we can solve that. And this problem is actually something that can be factored. So I factor this, and this comes out to x plus 7, and x minus 4 is equal to 0. I can solve each of these, I can separate these two parts into two separate equations because of the zero product property, and I get x equals negative 7, x equals 4. Okay? Now normally this would be the end of the problem, but keep in mind that the original problem asked me to solve for an inequality. Okay, so I have to be able to solve it for the inequality. So next what we're going to do is graph, okay? And again, some people like graphing, some people like it too much, some people don't like it at all. The most important thing about graphing, like any other methods, is that we have to be able to pick and choose when is the correct time. And when we're working with inequalities, graphing is really good. Okay? So I'm going to draw the graph here. And the first thing that I'm going to do is I'm going to put negative 7 on there somewhere. So I'll go two at a time. 2, 4, 6, 8. 2, 4, 6, 8. 2. This is negative 2. And I know that negative 7 has to be on there. So negative 2, 4, 6. So this is negative 7 right here. And positive 4 has to be right here. Now, what I'm really interested in is what's going to happen to the left of here. So, well, if I go to the left of this point here, will this be positive or negative? When I go in between here, will this be positive or negative? Positive or negative? And when I go to the right of the x-intercept, will this be positive or negative? Okay, so I don't really know yet. And the best way to do this is, again, just to graph. So I'll take out my graphing calculator. I'll type in the original equation, x squared plus 3x minus 28. My window, I've adjusted here a little bit. It's the y values are going to be huge, so I made the y min between negative 50 and positive 50 in increments of 5, and you can see the graph right there. Okay, so let me move this graph up here so I can draw it on this paper. And when I graph this, it becomes a very big help to me. So you can see that between the two x-intercepts, the graph actually bends down like this. And this is actually I'm going to have my graph increase in increments of 10, just because it's smaller here. Okay, so this is 10, this is 20, so on. So you can see that between the two x-intercepts, the graph is below the x-axis. And then to the right of the x-intercept, to the right of 4 here, so the graph is above the x-axis, and to the left it is above the x-axis. And so the question is, this is greater than, right? This line right here, greater than. So this means where, or for which values of x is x squared plus 3x minus 28 above the x-axis. And that's what this question is really asking. For which, since it's greater than, for which value is it above the x-axis? And so now these question marks, I can answer it definitively that if I draw this line here to separate this section, between here, this is negative, certainly negative here. To the right, it is positive, and to the left, it is also positive, okay? Because at this point here, this is my x-intercept. This is x equals -7. This is x equals 4. To the left of -7, the graph is positive. To the right of +4, the graph is positive. It's above the x-axis. And in between the graph, the expression that we have up here, is below the x-axis. So then my final answer is that x has to be less than -7, or x is greater than 4. And we got to have that or in there. And then I can also write this in interval notation, which is anything between -infinity and -7 exclusive, since we're using a greater than, or union with anything from 4 to positive infinity. And so there you have it, a way for us to solve quadratic inequalities. And we can actually solve a lot more than just quadratics using this type of method. But it's a combination of finding the x-intercepts and then using the graph to help us visualize and get the answers. Okay, so I've got another example here. X squared plus 5x is less than or equal to 36. And we're trying to solve for x again. And we know that the answer to this problem will also be an inequality. So like we did with the last problem, we're going to find the zeros, or the x-intercepts. So we're going to set this whole thing equal to 0. We're going to change this into an equal sign, x squared. Actually, I'm going to convert it to a 0 inequality first. So subtract 36 from both sides. Whoops. And I get x squared plus 5x minus 36 is less than or equal to 0. And then to find the x-intercepts, that's when we set this equal to 0. So x squared plus 5x minus 36 is equal to 0. And let's find these x-intercepts. And we are lucky once again that this problem can be factored. So let's factor it. This is x plus 9 and x minus 4. And this will give me x plus 9 equals 0, x minus 4 equals 0, so x equals -9 and x equals +4. And those are my two x-intercepts. Okay, so again, but they are not the solution to the problem. And this time again, I'm going to use my graphing calculator to help me graph. Now when I graph this, there's one thing that I know for sure. If this is 0, 1, 2, 3, 4, 2, 4, -2, -4, -6, -8. Make this a little bit bigger. -8, -10. So -9 is here. Okay. What I'm interested in is what happens in between here. Now there's a few things that could happen. The graph could go like this, or the graph could go like this. Okay? And I don't really know for sure yet, so having a graphing calculator with me is going to be a big help. So I'm going to graph this x squared plus 5x minus 36. Hit the graph button. And you can see there that the graph actually goes downwards. Okay, so now that I have that image there, I can, I'm going to go by tens here. And so by looking at this, between these two intercepts, it does something like this. And then just like last time, continues here. But now I'm interested in the parts where it is less than 0. See this here? In the last example, this was a greater than sign. So this is really asking for which values of x is x squared plus 5x minus 36 less than or equal to 0. Okay. So in other words, I want, if I draw some vertical lines here just to separate it, this is x equals -9, this is x equals 4. I know that to the right of this, the graph is positive. To the left of -9, the graph is positive. But between -9 and +4, the graph is negative. Okay, so I know then that my answer is x has to be greater than or equal to -9, but cannot be, and also has to be less than or equal to +4. So in between -9 and +4 is are all the possible values of x that will satisfy this inequality. And we can also write this in interval notation as between -9 and +4. And so there you go. We have another example of solving an inequality. And again, our goal here is really just to find the x-intercepts, okay, and then use the graph to help us identify the parts where it is actually below 0. So we're going to look at one final example here, where we are looking at powers of x that are even higher than x squared. So this is not a typo, this is actually x to the third, okay, and we're still asked to solve for x. So I'm going to set one side equal to 0, gives me 2x to the third plus 8x minus 4, okay, and that whole x expression to the right should be greater than 0. So you should ask yourself right now, what part of the graph do you want? Do you want the part of the graph that is above the x-axis or below the x-axis? And if you can answer that, you're in good shape. If not, just follow along with the example and hopefully it will become more clear. Now, I don't know of any algebraic way yet to solve this. So for right now, we're going to do this entire example entirely by graphing. So take out your graphing calculator. Let's see if I can move the glare there. Okay, and we're going to type in 2x to the third plus 8x minus 4. I'm going to go with the standard standard window here. Take a look. Oops. Let's see, did I mess up? Nope. Okay. And our question is, where is this graph going to cross over the x-axis? And I'm going to zoom out just a little bit more here, just so I know I can feel a little bit more assured that I'm not missing anything. Oh, you know what? I realized I made a mistake. I forgot a squared here. So this should have a square, and this should have a square. So that was the original problem. It should have had a square in there from the very beginning. Okay, so I'm not doing anything special here. I'm just correcting the original problem. Let me correct it in my calculator as well. So it should be 2x to the third plus 8x squared minus 4. And then we can graph it with the standard window. Okay, so that's roughly what it looks like. And again, I don't really know how to solve this algebraically yet. So the best thing that we can do right now is to solve this using a graph. Okay, so let's find the x-intercepts. Okay, so let me write a note here. Find x-intercepts. And it's nice because our calculator will help us do a lot of that. So I'm going to find the leftmost points here. Go to 0, the cursor just a little bit to the left, hit enter. So one of the x-intercepts is that approximately negative 3.870. Let's find the second one. Right about there. And another approximate answer is negative 0.790. And there's a third x-intercept. And that's approximately 0.660. So I've got these 3 points, and I'm going to use them to help me graph. So 2, 4, 6, 8, 2, 4, 6, 8. Remember to always give your scale. In this direction, I'm going to go by 5s at a time. Okay, and I have these all the important points here. Negative 3.87, so that's approximately right here. Negative 0.79, so that's about right here. And then positive 0.66, so that's right here. Okay. And then I want to know, in between each of these, where is the graph above the x-axis? Okay, because this entire expression here is greater than 0, I want to know for which values is the graph. Okay, because this right here is greater than 0, is the graph above the x-axis. So that's an important question to know. And so we can sketch this graph out here. We know that it's going to do something to this effect. And you can see here that there are 2 spots that's important. So between this x-intercept right here and between this intercept right here, the graph is above the x-axis. Okay, so that's one possible solution. Okay, so I know that it's one solution is that x has to be between about negative 3.87 and negative 0.79. So between these 2 intercepts here, the graph is above the x-axis, and then it goes down below the x-axis, and it goes up again right after it passes this point here, or x is greater than or equal to 0.66. So let me write this neater here. I don't like sloppy math. So negative 3.87. And so that entire statement there is my answer. And I can also write this in interval notation. So the first part between negative 3.87 is my left bound. My right bound, or my upper bound, is negative 0.79. And this is inclusive. Union, remember that anything from 0.66 onto positive infinity. And there you have it. This method that we're solving for here, it's not great. It's giving us approximate solutions, which is not ideal, but a lot of times that's all you need. That'll work out pretty well. And notice we solved this entire problem using graphing, not using any algebra at all. You can certainly do this for the other problems as well, but you know, graphing can be tedious sometimes, so I use it for the problems that are truly difficult. And we can just look at this as the expression is greater than 0, so we're looking for all the parts that are above the x-axis, and our answer is the x values that capture those parts.